This video discusses the use of the trend-adjusted exponential smoothing method or Holt's method for forecasting. This is an additional example. In this case, the time series in question is the randomly simulated data from the year 2008 through 2013. The goal is to create a forecast for the data first for year 2014 by using trend-adjusted exponential smoothing, and then forecast values for 2015, 16, and 17. We need to calculate two components of the forecast: the smooth forecast denoted by F in the template, a trend component denoted by T, and the forecast including trend is represented by FIT. The trend-adjusted exponential smoothing can be thought of as an exponential smoothing forecast combined with an exponential smoothing forecast for the trend. As with the regular exponential smoothing method, we need a starting value for the smooth forecast. The typical assumption is to just use the first actual value in the time series. We also need a starting value for the trend component, and we typically use 0 for the starting year. The forecast including trend is the sum of smooth forecasts and the trend component T. This formula is not going to change, so we can drag down the formula until 2014. Of course, there are zeros for every year but the first one, but this will change as we fill in the formulas for the smooth forecast and the trend component in each year. The smooth forecast works just like a typical exponential smooth forecast, and it's going to be the prior year forecast, including trend, plus the smoothing constant alpha times the forecast error, which can be found by actual data in the previous year minus the forecast in the previous year. I will put a dollar sign in front of and after C in the reference to the alpha smoothing constant because that will always be referenced from C1. This will allow us to copy down this formula until 2014. Next is the trend component. The trend component for the current year is the prior year trend component plus trend smoothing constant beta times the current smooth forecast minus the previous forecast including trends. I will put dollar sign. This parenthesis represents the error that comes from the trend. When we adjust the smooth forecast with trend, our forecast will be adjusted either upward or downward. This formula can be copied down till 2014. To forecast future values, we will use this final algebraic form. Starts with h sub t plus m. What is h sub t plus m? This is the Holt's forecast value for period t plus m. H sub t plus m is equal to smooth forecast at period t plus a constant m times trend forecast at period t. So let's start with 2015. For 2015, H becomes sub 2014, t is 2014, plus 1. As you realize, m is 1 for 2015. Since 2015 is one period ahead of 2014. H sub 2014 plus 1 is equal to smooth forecast at 2014 plus m times, which in this case m is equal to 1, times trend forecast in 2014. Let's do for 2016. Now for 2016, m becomes 2 because 2016 is 2 periods ahead of 2014. We will choose smooth forecast in 2014 plus now m becomes 2 times trend forecast in 2014. Let's do it for 2017, f 2014 plus 3 times trend in 2014. So this is how we forecast the future values. As you realize, to forecast future values, we don't use FIT, we use FT plus M times T sub T. The reason is simple. Since we don't have actual data for 2014, 15, 16, we need to use a different algebraic form to forecast for future periods. So let's plot actual data, select data, add actual data first. And just be careful, don't select until 2013, select all the years. Let's edit the years. And then let's add our forecast. So now you can be able to see how we forecast the data in the historical data, and there is a part for the future period. To calculate errors, we are going to get the difference between actual data and our forecasts. And you can calculate errors until 2013. As you realize, for the first year, error is 0. You need errors to calculate root mean square error. So that completes this video.